Welcome to a year of headaches. How not to build a real-time multiplayer game. So it was the summer of 2022. That's last summer, and I started work on this project that I intended to present at Flutter Vikings that year, last September. But I'd never made a real-time multiplayer game before, so I had no experience solving the class of problem that I was about to face. And things got tricky very, very quickly. So fast forward to just T minus 3 weeks till Flutter Vikings. I had a working game nowhere in sight. I realized I needed to pivot, and that's when I started working on the lifetime of a widget. But then, the problem was after Flutter Vikings, I was just so burned out, so tired of this project that I couldn't look at it or think about it for 8 months. And it was not until this past April that my burnout had kind of faded a little bit. And I had a new idea of maybe what was wrong the whole time and got back on it. And now here we are. So as Samuel L. Jackson says in Jurassic Park, hold on to your butts and get ready to learn how not to build a real-time multiplayer game. Now, at this point, you're probably thinking, I made something really cool, like multiplayer Stardew Valley or Minecraft or something. But no, I made Pong. That's right, real-time multiplayer Pong took me months to develop. And to set up how, I should share my constraints. So first of all, I wanted my game to be deterministic. I'm really smitten with game sessions that you can replay off just the user's inputs, and I knew I wanted my Pong client to be capable of that. So in practice, this means that there's no randomness when we're calculating how the ball bounces. Everything is predictable in advance. And then two, the implementation needed to be observable. I knew that I wanted extra sessions to be able to attach to a running game and follow along. And then, in fact, for the purposes of building all this for a talk, I also decided that there would actually only be one running game of Pong ever, and that any other sessions that connect would be observers. And if you're wondering, yes, this does mean we're going to play Pong as a room together at the end, and two of you will battle it out. And we'll watch you on the big screen. Okay, three, the implementation needed to be scalable. With the possibility of everyone in the room loading the app on their phones and anyone on a live stream, I don't even know if there is one. I knew that sending the full game state to every client, every tick, just was gonna be a non-starter, so I needed a more efficient communication strategy. And then four, I wanted the game to be server authoritative. Obviously, that helps you prevent cheating, because the server can reject bogus commands and is the ultimate source of truth, and so that's great, but it does add some extra headaches. You have new questions to answer in terms of how you render things, right? Imagine a player presses the key to move their paddle in the game. You have two options. You can either render that right away, and in that case, you're rendering this kind of phantom state that the server and no other clients agree with yet, or you can wait until the server verifies the movement, but that guarantees a really stuttery, kind of terrible experience for the player. So that former strategy, that's called optimistic updating, just like in our non-video game apps, and it's considered a best practice, but it does kind of open the door for some chaos later on. There's other implications as well of being server authoritative. Flame, obviously, great client-side 2D game engine. And some of its best features, in my opinion, are obviously that game loop and collision detection, but those have a less obvious application in a server authoritative game. So I did still use Flame for its client-side game loop, but I had to roll my own server-side game loop and collision detection. So that's it. Multiplayer, distributed, real-time, observable, server authoritative, scalable, deterministic Pong, or multi-Pong, as I came to call it. It can't be that hard, right? Well, I made it look hard, so let's find out what happened. So to start, here's the backend architecture that I first came up with. And I'm using Cloud Run as the backend. Typically, Cloud Run is not a viable runtime for stateful applications, because Cloud Run is strictly stateless. But I didn't know how to use a Kubernetes cluster, and I didn't want to learn, so I had to get creative. And I said that there's at most one running game of Pong at any given time. So that means that there can also be just one game server running the actual application logic. So at the center of my backend universe is this single Cloud Run service capped at one worker node. And whenever the one game is being played, that worker node is alive and computing. And I call this layer the game server. This is not at all how Cloud Run was intended to be used, but what are you going to do? Now, by default, Cloud Run instances have a maximum number of concurrent connections, and that's 80. So if I stopped here, I'd be able to support 2 active players and 78 observers, but I wanted to aim bigger. So meet a wrapping layer of Cloud Run servers that are properly stateless, and clients connect to these servers, and they have no job other than to ferry user commands into the game server and then fan out game updates to any connected clients. And I call this layer the front line. Now, this brings my maximum number of supported clients to 6,400, which is, of course, 80 times 80. Okay, so it all works like this. Imagine everything's dormant. No one's been playing the game for a long time. All the servers are turned off. And then somebody visits the domain, and a Flutter web app spins into action, and it opens a web socket connection to that frontline service. That opens up a node and starts its process. It then opens up another WebSocket connection to the backend to wake it up, and now the whole system is alive and ready for another client to connect. And when that second player appears, then the game server starts an instance of this Pong game class, which simulates all the intricate, advanced logic of Pong, and it tells it to start simulating, and then it elevates those first 2 connections to become active players. And it starts pushing game events out on whatever WebSocket connections it has open. Then when additional clients connect, they get kind of an initial payload of the full game state, and they're able to start following along. Now, all of the clients here are similar in most ways, except the active clients are just able to issue commands that the servers won't throw away. But all the clients are kind of also observers in that they receive updates about the game via the exact same mechanisms. And then if you're lucky enough to get more than 80 people connected at the same time, which I have never tested, then in theory, the frontline Cloud Run service will add another node, and multi-Pong can scale. So obviously, this is full stack Dart. You know there's going to be a ton of shared logic here. Multi-Pong has a ton of classes that span the front and back end, from the whole game state to game events and message and response objects that ferry them across the wire. But that single most, or that Pong game class there ended up being the single most important class in really the whole code base. And my understanding of what role this class needed to fill really evolved over the course of development, and that's a lot of this talk. So let's take a quick look at this Pong game class. It has 2 primary communication ports. The first one is a method by which it hears about outside events, and I eventually realized that basically just needed to be whenever a paddle moved. So it's got a method where it hears about outside events, and then it has a stream from which it broadcasts its own internally simulated events out to the outside world. So how does the Pong game class work between those 2 communication ports? Well, I mentioned earlier that a server-side, or like a typical game loop from Flame, doesn't have as obvious of an application on the server. But like, why is that the case? You know, it's not Flame's fault. It would be any full-speed game loop. Because this is Pong, right? We know where the ball is, we know where the paddles are, we know where everything's going. We should be able to simulate when the ball is going to bounce into something next, and that really calls into question what's the value of having the server run an update method 60 times per second. Obviously, the client still does need a conventional game loop, so like I said, I used Flame on the front end. But the server doesn't render anything, so it's not beholden to that. So this was the pseudocode that I came up with for the server-side game loop. So we calculate the ball's next position, and then we go to sleep until we expect that collision. I think I said position a second ago, I meant collision. We go to sleep until we expect that collision to happen. Then we wake up and we apply that collision to the game state. So we bounce, we change the ball's movement vector, all that kind of good stuff. We cache the ball's location, and then we do it all over again. So this is the kind of first draft of the server-side game loop that I had. Now, this isn't much of a game yet because players can't do anything, and players do, in fact, have to influence the flow of a simulation before you could call it a game. So consider this scenario where the ball is currently on track to score a goal in that upper left corner, and that's what the game is expecting in its next collision. But is that still true after the left paddle starts to move up? Like maybe it is, maybe it isn't. So what this is going to do is throw away that old next collision value and then calculate where the ball is going to be when it intersects the paddle's plane, calculate where the paddle is on track to be at that moment in the future, and then calculate the new expected next collision. So this means that that set paddle movement method that we saw earlier has a couple more jobs to fill. One of them is to cancel the previous next collision prediction. And then also it needs to kind of kickstart another server-side game loop that starts predicting next collisions. And then that schedule next event method, it also, of course, has one more job now, which is to just bail if its next collision variable has been canceled while it was asleep. So this game loop is pretty efficient. It doesn't run 60 times per second. It just runs 1 time per game event or user input. That means that Pong game class gets to spend most of its time asleep, probably not unlike most of you in this talk. So the last major character to get to know in this drama is the Pong game state class. And this has all the interesting bits of a running game of Pong. Of course, I used freezed for this, and basically every other data class in multi-Pong. And some of its important fields include, obviously, the score. And then we saw that last, that kind of cached last known ball position. This is the last time it bumped into something. And then there's a similar mechanic for the 2 paddles. Oh, I did forget a sentence here that I want to say. And in the end, getting this game working was really about figuring out the right shape for this class, right philosophy for this class. So I don't want to spoil that yet. Just know there are some problems here. Okay, another interesting thing, of course, multi-Pong needs to be able to run on multiple screens of different sizes, different aspect ratios all at the same time. And that means that obviously it can't store the position of any game objects in terms of screen pixels. No serious game can do that. And so for multi-Pong, I decided to store my XY coordinates in terms of floating point numbers normalized for the shorter side of the game area. And I'm always using a 5:3 aspect ratio. So that means my Y coordinates are normalized between 0 and 1, and my X coordinates are normalized between 0 and 1.6667. And this is kind of a fun part of game development. Like, you get to invent whatever coordinate system you want, whatever makes sense for you in your game, and this is what worked for me. So right now, you might be thinking like, okay, I mean, this doesn't seem so bad, like maybe a little tricky. What went wrong? Well, the biggest thing that went wrong is I just didn't have, I didn't magically have all the right ideas in my head when I started the project. So what we've seen so far is actually just my initial vision that contains a ton of problems. So if we go back to that architecture diagram, the server situation, that never had to change. That was fine, but what code ran where definitely did. So originally there was just that one running instance of the Pong game class, and it would spam game updates out on the wire every tick. Actually, no, it wasn't every tick. I think it was every event. But that meant that the clients could render an initial game state value that they got, and Flame knew how to move something from one frame to the next, but it didn't know anything about when an upcoming collision would happen or how the ball should bounce or even like the game boundaries. And it might not surprise you to learn that this was an absolute failure. This build of the game was just hilariously bad. The paddle and the ball would just lurch about the screen where, it looked like total chaos. And I still remember laughing out loud at just myself and like how utterly broken this first build of multi-Pong felt. And so once I realized that my UI would always be stuttery and terrible as long as I was completely dependent on updates from the server to do anything more than advance the ball in the current direction, I started to think about how I might have a shared simulation that was running everywhere. And so with this idea, I moved that Pong game class out of my server code into my shared code, and I rethought everything. And this was the first time that this idea started to enter my thinking, which was that Pong should be completely deterministic, but for the player's inputs. And it took me a long time to fully appreciate what this sentence even means. So to visualize the implementation again, this is just kind of how it works. You've got the ball here. You calculate where it's going to bump into something. Then the server or the Pong game class wakes up, applies that movement. It updates the ball's new kind of saved last known location. Do the same kind of thing for paddles. So when they start moving, you update some of their fields. When they stop moving, you update all of their fields. And this is enough for this class to enter its infinite loop of calculating the next collision, going to sleep until it happens, waking up, applying it, and so on. And with this in mind, then my design shifted from what we saw before to one where the Pong game class is now running everywhere. And my hope was, Well, as long as they just have the same values in their state class, then they should all predict the next, the same next collision, and they should all be able to render the same thing. We'll see how that went. And Flame would use an API like this to figure out where to draw the ball from one frame to the next. It would start with that last known collision again. This is, maybe it bumped into a top wall 300 milliseconds ago or something. That's a vector 2. And then we'd calculate the vector 2 for how far it should have moved in those 300 milliseconds after it last bounced. And that gives us the coordinates for where to draw the ball on this given frame. Okay, this is the big refactor. It was time to test again. I was all excited. Played against myself in multi-pong. I've done that so many times. I'm freaking sick of multi-pong. But it was working pretty well for like a few seconds. And then I saw the first instance of a bug that was going to plague me for months. And that was just 2 clients completely desyncing and rendering totally different game states as if they weren't even talking to the same game server. And I was like, there is only one game server. You're both talking to it. Like, come on. And for the rest of my development, honestly, easily 100 hours of intense effort was spent tracking down and fixing all the ways that my game was leaking accuracy. And it was a ride. Okay, my first big insight here was that clocks are the worst. So it's a well-known problem in computer science that you can't get 2 different computers to perfectly agree on what time it is. Obviously, there's NTP, or Network Time Protocol, to get 2 computers separated by the internet to loosely sync their clocks, but I said I wanted complete determinism. So I thought, well, I need at least millisecond precision and like maybe microsecond precision. And in multi-pong, this limitation of physics kind of hit me in the mouth right away. So let's say it's noon and the game server starts a game because 2 clients just connected, and it sends out a start game signal to all the connected clients. So that travels to each computer or phone running the game. They start their simulation, but they're now behind the game server, and they have no idea how much time has elapsed since that message was sent. And this makes it very difficult for any of those games, any of those running client simulations to know what to make of a command that they receive from the server. If it has, if it has a date time in it, if it says like at noon and some amount of time do something, this is very confusing for the end clients because they don't know how far behind they are. So to solve this, I realized it actually doesn't matter what time any of the computers think that it was that the game started. They should all just privately note what time they had on their watch, and then think about everything that happens in the game in terms of a duration value since that start time. And then everything in multi-pong started to run on this very, very simple getter called runtime, which again just returns that duration since the start. And so again, just to kind of see why this is true, it's noon, a game starts. And then that signal goes to a computer that has like some other amount of time, or there's some other time drift. Let's say this client is 3 seconds behind the server. It's not like 3 seconds of travel. Its clock just reads 3 seconds slower. So then imagine 1 second into the game, the right paddle moves up, and the server disseminates a command that says, at 12 o'clock and 1 second, the right paddle moves up. Right? That's 3 seconds in the future when it gets to the client. But if instead that command says, move the paddle up 1 second after your game started, then all the clients are like, aha, I know what that means. I need to move the paddle now. So date times are the worst, they're out. Durations are the best, they're in. And this was one of the first moments, actually no, it was the second one. We already talked about one. This was a moment where once I spotted this flaw in my design and fixed it, I honestly felt pretty silly that I'd ever thought the first strategy was gonna work, because it just obviously wasn't, but that was only in hindsight for me. So I finished this refactor, was excited to test myself, or play against myself again, test it out, thought it might work, still totally desyncing all the time. So I scratched my chin for a while, stared out the window, and I was eventually able to reason about another possible source of inaccuracy. And the culprit this time was clocks again. So yeah, they're the worst. So remember when I said that an event would get scheduled for the future and then it would, the simulation would wake up and apply it? Well, you might be surprised to learn that in Dart, when you schedule a callback with a future, your callback is not likely to be executed at precisely the time that you indicated. And this isn't Dart's fault, of course. No running program can guarantee that it will even have the operating system's focus at some future moment. So what tends to happen is your callback gets executed really close to when you specified, but plus or minus a few milliseconds. And I was starting to theorize, well, wait a minute, if I'm calculating how far something has traveled based on the elapsed time, and different simulations are waking up at slightly different intervals, they're gonna calculate different distances traveled, they're gonna calculate different bounces, and maybe that's why my game is desyncing. So this was the code that was waking up and applying that travel time on some object in the game, here the ball, and I realized that that game.runtime was calling datetime.now, and datetime.now is baking in any of the errors that we have in when this future just happened to resolve, when the operating system got around to it. So I realized that instead of asking the clock what time it was when I applied a collision, I should instead just pretend the time was exactly what I intended it to be when I scheduled the event. And this, in theory, was going to be able to remove any possibility for two simulations to get pretty unlucky, wake up at different times, and then disagree about what's happening in the game. Okay, once this refactor was done, honestly, the refactor wasn't much more complicated than what you just saw. It didn't take that long. I relaunched the game, played against myself again, and still totally broken. Yeah, the breakage was not to end anytime soon, it turned out. So in the weeks following this, I entered a pretty prolonged drought of ideas for what on earth to fix. Multipong would work until it didn't, and what exactly went wrong was really hard to reason about. So then I started to think, all right, I need better visibility into what is going on under the hood here. So I theorized, more logging is definitely going to be better. When you watch two silent simulations start to deviate, you've got nothing to go on. So I added these targeted log statements, and video cannot be loaded. Rats. Well, it's a bunch of terminals with logs just flying by. And at this point, this is when I say, oh my God. So performing root cause analysis on just multiple fire hoses of terminal logs is actually less fun than it looks like, and you have to imagine what it looks like. So join me in doing that, please. It's a lot of logs, right? Yeah. And then to make matters worse, I couldn't even be sure that the culprit for my error was captured in these logs that we have to imagine. So it was like the ultimate needle in a haystack problem, except no one could guarantee to me that my haystack even had a needle. So at this point, you could tell that I was really feeling the despair, because I started to think like, well, maybe it's like logically impossible for this game to completely avoid, differences of opinion and chaos and whatnot. And so I entered a new phase of development. Oh, it's ticking through the video that didn't play very slowly here. I entered a new phase of development all based on error correction. And so then I started to think, instead of preventing all the errors, how quickly can I detect them and correct? So the kind of central thread here was like, wait a minute. These simulations are supposed to be perfect mirrors. So what if I had my client compare the stream of events that its simulation emits with whatever we get from the server, and these lists should always be the same. So anytime that we see one list on the client not have a twin, then we have a problem. So what if I stop trying to figure out where this disagreement is coming from and just have a full reset to the server every time this happens? Like, that should work, right? Well, this was an enormous refactor, but eventually everything was coded up, and I started to face myself in Multipong for the 20 trillionth time. And sure enough, the clients desynced because I hadn't added anything to fix that. My error correction mechanism would kick in, and didn't work. The reset would just as often add more chaos as it fixed anything. And this part really bothered me because I was sure that conceptually this strategy should work better than I was seeing, but I was very stubborn, honestly, at this part, and I spent way too long trying to debug what was going on here, but I never did figure it out. I never found the culprit for why my reset strategy was just as often an agent of chaos as it was helpful. And this was where things sat when I walked away from Multipong for 8 months. And then As I wasn't working on multi-pong, I started to think to myself, how do bigger video games do this, right? Like, what is going on? And I thought back to this moment from a few months before. My wife and I used to play World of Warcraft together, and we would sit on the couch and with our laptops and play. And there was one day, and I pointed this out to her, we were standing next to each other in Darkshire, if anyone's played WoW. And I was like, look at this. Our screens don't agree on anything. Like, every character on my screen is in a different spot on your screen. Every NPC is in a different spot on your screen. And I realized that this actually just kind of doesn't matter in a game at WoW's scale, where if my character is standing here or here is like not relevant to anyone else in the game. And, but Pong is very different. The game area in Pong is small. There's only 3 things that are moving around, and the player can see everything. And unlike WoW, where a whole foot doesn't really matter, 1 pixel can be the difference between whether or not the paddle gets to a location in time and intercepts the ball or not. So obviously, I wasn't making something harder than World of Warcraft, but I realized that in some ways, I had taken on less forgiving constraints. And at this point, man, I was really burned out. So like I said, this is where 8 months passed, and I could neither touch nor think about multi-pong. But then this April, I had a few new ideas, and I got back on the horse. So please work arrow button. There we go. So what I realized, much to my own deep embarrassment, is like, wait a minute, I never even made multi-pong properly server authoritative like I said I was going to do, because I was afraid of UI easing and all of the stuff that implies. So what would happen is whenever a player would indicate that they wanted their paddle to move, they press a button or swipe on your phone or whatever, and the client would send that message to the server, and it would attach its local runtime. Remember, that's the duration since the start of the game. It would attach that to the message, and then the server would use that value as written. And the problem, I realized, was that that might be in the past for the game server. And the floodgates were opening for me now. Everything was becoming clear. I realized that this was not going to play well with how I was caching the ball's last bounce location. So this was the scenario that I started to reason about. Imagine all of the simulations agree that the ball is about to collide with this right paddle. And so the server wakes up and it applies that collision. It calculates the ball's next path. It's ready to continue on in this point. But then it receives word from a client that's like, well, actually, that paddle started moving a little bit ago and it got out of the way. And so in this scenario, we can see that the simulation on the left doesn't apply the collision. It's just ready to keep on going and have that goal get scored. Now, the server does accept the paddle movement, but I never had anything go back in time and sort out the mistake that was made. That cached ball last known position was my problem, because that is what is making the server now think that this point is continuing. So we can see there the client thinks a goal is scored, it's ready to reset, but the server just keeps bouncing the ball around in this point. And I figured that has got to be where my error is coming from. And the error correction system would wake up and just make everything worse, but I was ready to not think about that anymore. So I thought about this for a while, and I reasoned that there were 2 things that I had to do to finally fix multi-pong once and for all. And the first one was, of course, that it had to actually be server authoritative. So the server was going to start setting the time of a movement, and it was not going to trust what the client said anymore. A lot of people consider server authority important just for cheating prevention. Of course, it is important for that. But for multi-pong, it was proving to be important for just basic accuracy. But I knew that that wasn't the only thing that I had to do. I also had to revisit this sentence that multi-pong should be completely deterministic, but for the player's inputs. And it was caching the ball's last location that was orthogonal to this idea and was breaking the vision that I'd always had. So, it was, like I said, caching the ball's position that was causing this part to break. So I finally had to make multi-pong actually deterministic. That was idea 2. And there were 2 truisms around determinism that occurred to me at this point that were going to make this actually a thing, once and for all. And the first one was that given the player's inputs, I should always be able to calculate where a paddle was at any historical moment. And then the second idea was that as long as I can calculate where the paddle was at any historical moment, I should be able to track the ball's full historical path from the start of the point to the current moment in time. And this changed everything. So I revisited this Pong game state class, and I was like, you last known position fields, you're out of here. I scrapped them, and I replaced them with the history of movement commands that either player had issued this game point. And once I figured this out, this was time number 20,000 in this project, where I felt very silly that I had ever thought my previous idea was going to work. As soon as I had the right thing in front of me, what I had been doing before felt very, very silly. So my API for determining where a ball was on any given frame changed from this old method that we saw before, because it uses that last cached ball position, and it morphed into this new algorithm that I think is better visualized. So imagine we're 2 seconds into the game, and we need to figure out where to draw the ball. So we calculate its first movement, and let's say it's going to take 1.2 seconds to get to this bottom wall here and bounce. So we apply that much movement. We've still got 800 milliseconds to go. All right, where is the ball going next? Well, it's headed toward the left wall to score a goal. But this one gets interesting because we have to ask ourselves, was the paddle there? Luckily, we can calculate historical paddle positions. So let's say we crunch those numbers and it turns out, yes, the paddle was there. Okay, great. So we calculate this collision, we apply it. Let's say we've got a few more milliseconds to go. We work out how much movement the ball should have done in 200 milliseconds. We apply it, and that's where Flame draws the ball on this given frame. So this was the one refactor to rule them all. It was bigger than all of the others combined. But once I had this in order, I played against myself again, but for a couple errors in my own implementation, it actually just worked. Finally, multi-pong was staying in sync. I was able to play whole games against myself, and I was like, all right, I'm going to talk about this FlutterCon Berlin. Woo! Thank you. Thank you. Now, there was still the matter of UI easing that I'd been avoiding the whole time, right? When you allow the client to say when the paddle started moving, that makes it very easy to allow the player who's controlling things to see an immediate response to their click. But luckily, my win streak continued, and I had a pretty good idea. At least I thought it was good. I hoped it would be good. And I thought it might hide about, at least 99% of jumps in the UI. And the trick was pretty simple. So what I did was write to that paddle movement log, which remember in this new world, writing to the history of paddle movements is the only way to change the ball other than the only way to change the UI other than the ball bouncing around on its own. So I would write to that log, and I would use the local time. So let's say 100 milliseconds into a point, the player presses a button. I just use 100 milliseconds for now, and I'd start rendering because of having written that log. Then we send it to the server, and we allow the server to flex its authority, and it says, maybe after 150 milliseconds of travel, the server is like, well, no, this actually happened at 250 milliseconds. So, okay, that's fine. The server, I hit the wrong arrow. It's really hard to always hit the right arrow. So then the server broadcasts this back to all the clients, and including the active client that initially issued the command, and it overwrites its old value of 100 milliseconds, replaces it with 250, but it notes the difference between those two, that 150 millisecond gap. I started to call this the paddle latency, and if you factor this in, this is Flame's job now, factor in that paddle latency to where you draw the flame, or draw the paddle. It avoids that kind of jumping around when the paddle history gets rewritten underneath it. And the same strategy works in reverse. When the user lets go of the key, stop the paddle moving immediately, and then it all just kind of happens. The paddle basically comes to an immediate stop, and that's very close to where the server thinks it should have stopped. And then I would just snap it into place. If it was off at all, that usually ends up being like 1 or 2 pixels. The user can't even tell. So I'd been afraid of UI easing for almost a year, but then when I finally forced myself to solve it, it literally took like 10 minutes to get right. The API for it was very, very simple. And after a year of headaches, I'm not gonna lie, this win felt really, really good. So if in general, reactive UIs follow this formula where the UI is a function of state, I was able to achieve this in multi-pong by realizing that my state was just the paddle movements this game point. Now, there were a few just kind of random musings that I was making along the way that I want to share real quick. And one is that correct code is often shorter. Like, I spent a year incrementally approaching the right idea for how to make this game, or a right idea. And without fail, every time I had a good idea, my implementation would get shorter and more concise. And every time I had a bad idea, like some convoluted error correction mechanism, my implementation would expand and get more verbose. And this is not an absolute statement, of course. It does not apply to individual functions. Like, some algorithms are just necessarily complex to get right. But in general, the more closely your strategy reflects reality, I think the less error correcting, the less juggling you should find yourself doing. And then a corollary to that is that good ideas often look easy. There were so many times where I would be banging my head against the wall on something, I'd finally get it working, and what worked was the simplest thing I'd ever tried, of all of my failed attempts. And I'd be like, this whole time, all I had to write was that? So if you're struggling with something, you finally get it working, you feel silly that it took you so long to see the right solution, cut yourself a little slack. All right, if you are so inclined, you can load multipong.app on your phone. This is the just beautiful UI you will see. And if you have any red on your screen, you are an active player, and you can play by just dragging your thumb up and down anywhere on the screen, and that'll move your paddle. I am now going to attempt to load this as well, and hopefully just spectate, because I want two of you to play. Okay, here we go. Oh, we've got a lot of viewers. I've never load tested past only a few viewers, or a few connected clients. So we've got Harsh Gift battling Pond Trade. Harsh Gift rises up, blocks the ball. Oh wait, no, it glitched. None of you saw that. Let's see what happens. I've never tested above like 5 connected clients. Oh no. Everyone refresh the page. Anyway, that's Multipong. Woo! Obviously, it needs a little more Q&A, of which it's had none outside of it started working last night. All right, where am I in time? Probably over. I have 5 minutes. Wow, okay. This was a meandering tale that I had no idea whether anyone was going to find interesting. But does anyone have any questions or comments?